Networking concept. Learning objectives. In this chapter, the user would learn the following in detail: networking, local area network, metropolitan area network, wide area network, network topologies, networking cables, Internet working devices, communications protocol, Internet protocol, IP address, MAC address, subnetting. Networking. A network is a group of systems. They are connected to allow sharing of resources such as files or printers, or sharing of services such as an internet connection. There are two aspects of setting up network: the hardware, which is used to connect the systems together, and the software, which is installed on the computers. It allows them to communicate with each other. The network hardware is made up of two basic components: the entities that want to share the information or resources, such as servers and workstations; the medium that enables the entities to communicate, which is a cable or a wireless medium. There are many types of computer networks: home area networks, wide area networks, campus area networks, metropolitan area networks. Local area network, LAN. A local area network is a computer network that interconnects computers within a limited area, such as a home, school, computer laboratory, or office building, using network media. The stations on the network are peers. Any station can initiate data exchange. It can be done with any other station. Full connectivity among all stations. It is fully administered by the owner. It runs over a shared transmission. The medium may be often cabling. The network is confined to a small area. It may be with a single building or a cluster of buildings. The data rate is high, several Mbps. Purpose of a LAN. A LAN permits users to share resources, hardware, software, or user-created files. Sharing of resources makes it possible to maximize the investments made in each resource. Ideally, distant resources should appear to be local to the user. Objectives of an effective LAN. When implemented, LANs are expected to achieve certain basic objectives. They are to improve employee productivity, to improve information management. Benefits of a LAN. Also, when implemented, LANs are expected to achieve certain benefits: to improve interaction between staff, to reduce or control costs. When implemented, LANs are expected to provide following benefits. It provides standardized hardware usage. It also facilitates standardized software usage. Fundamental requirements of LAN. An effective LAN is one that meets objectives while fulfilling certain fundamental requirements. They are simplicity and reliability. An effective LAN enhances certain basic needs. They are transparency and manageability. Characteristics of a LAN. The first characteristics used to describe the architecture of a given LAN. These characteristics allow for comparisons. It is compared among the many varied LAN environments. They are transmission medium. It is nothing but the type of cable or wireless system. It is used to connect the network devices. The second characteristics used to describe the architecture of a given LAN or topology. The topology deals with physical appearance. It also says about manner of operation over transmission medium, the particular medium when used to connect network devices. This characteristic feature also allows for comparisons among the many varied LAN environments. The third characteristics used to describe the architecture of a given LAN. Access control method. In a LAN environment, many devices share a common transmission medium, but generally only a few are able to use it at any given instant. Access control determines the way in which network devices are granted or denied access to the transmission medium. These characteristics allow for comparisons among the many varied LAN environments. Evolution of LAN. A LAN is only one type of computer network. Before LAN came into being, there were other types of networks. The original messaging network, the telephone system, did not even involve computers. Computer networks came into prominence after the appearance of computers in the corporate world in the 1950s. History of computer networking. It is geographically dispersed. The university research mainframes are connected. It was done for defense-related work in the United States during 1950s. The first commercial mainframe commission in US. The network used for airline passenger in 1964. They were used for information and reservations in the United States. In 1968, nationwide air traffic control in the United States. In 1970s, the Advanced Research Projects Agency network connects computers from multiple vendors scattered across the United States. 1980, Xerox, Digital Equipment Corporation, and Intel announced the Ethernet standards for office networking. The 1970s saw the introduction of mini computers, minis, essentially scaled-down version of mainframes. Minis are generally less powerful than mainframes, supporting fewer terminals in simultaneous use. The lower cost of minis permitted smaller companies to afford their own computer, allowed large companies to buy several low-cost minis as computing services became necessary for a given department or region. Basic elements. Basic elements of LAN. Local area networking and metropolitan area networking. A LAN is made up of three basic elements: the hardware, which is connected to form the LAN, the software or a program which access through the LAN, the users who create, work with, and manage the various files. LAN hardware. A LAN can be thought of a certain system composed of a series of building blocks. These blocks can be added and configured as needed. The hardware components found on a typical LAN include the following items: transmission channel, the medium which connects the network devices, network interface cards for attached devices. The hardware components found on a typical LAN include the following items: servers, file servers, print servers, communications servers. Hardware components of a LAN. The hardware components found on a typical LAN include the following items: stations, local, remote, hubs and switches. Wireless systems. Wireless transmission media is used to connect network devices. Wireless systems do not physically connect network devices since the links between the devices are invisible. They are either infrared light or radio links. Infrared links. Connecting devices using infrared light signals work essentially the same way that remote controls work with television sets. Radio links. This second type of wireless media uses radio waves to transmit information between the server and the stations. Advantages and disadvantages of wireless. Advantages: can be used in situations where it is difficult or impossible to install cable. Disadvantages: Typically, such systems are not able to meet the performance demands of large or busy networks. Transmissions can only occur over limited distances. Topologies. LAN topology is determined by how transmission channels are used to connect network devices. It is acknowledged that topology is the foundation of a LAN. First, topology refers to the physical appearance of the LAN. This is known as the physical topology. The second aspect refers to how the LAN functions. This logical topology is determined by how the messages are transmitted from one device to another. Bus topology. When a message is sent on this topology, the following takes place. The transmission signal leaves the sending device and travels along the cable in both directions. The device for which the message is intended will recognize the transmission and read the message as it passes by. Advantages of bus topology. It is easily adaptable to many environments. It can be configured to suit most situations. It is easily expanded by adding devices at any point along the cable. Ring topology. Ring topology. Advantages. When a message is sent, it travels from device to device around the circle. The sending device sends its message towards the destination device. There is no reliance on a central device. All messages pass through all the devices. Additional network devices can only be connected while the network is inoperative, since breaking the ring would cause network failure. If any device fails, the entire network is affected. Tree topology. The tree topology is an extension of the bus topology. By adding cable extensions to the basic bus topology, a larger network can be achieved using less cable. Each additional cable extends from the underlying bus structure and supports multiple network devices along its length. The three most popular types of LANs are Token Ring Network, FDDI, Fiber Distributed Data Interface Network, and Ethernet. Token Ring Network, originally developed by IBM in 1970s. Still IBM's primary LAN technology. In cases of heavy traffic, the token ring network has higher throughput than Ethernet due to the deterministic non-random nature of the medium access. It is used in applications in which delay is when sending data must be predictable. It is a robust network, that is, it is fault tolerant through fault management mechanisms. If any device fails, the entire network is affected. FDDI, Fiber Distributed Data Interface. FDDI is a standard developed by American National Standards Institute for transmitting data on optical fibers. It supports transmission rates of up to 200 Mbps and uses a dual ring. First ring used to carry data at 100 Mbps. Second ring used for primary backup in case first ring fails. If no backup is needed, second ring can also carry data, increasing the data rate up to 200 Mbps. It supports up to 1000 nodes and has a range up to 200 km. Ethernet, first network to provide CSMA or CD. Developed in 1976 by Xerox PARC in cooperation with DEC and Intel. It is a fast and reliable network solution, one of the most widely implemented LAN standards. It can support data rates in the range of 100 Mbps to 10 Gbps. It is used with a bus or star topology. Metropolitan Area Network (MAN). The communication infrastructures that have been developed in and around large cities, commonly used in school campuses or large companies with multiple buildings. It is larger than a LAN but smaller than a WAN. It is also used to mean the interconnection of several LANs by bridging them together. This sort of network is also referred to as a campus network. There are three major technologies used to develop the MAN. ATM, asynchronous transfer mode, SMDS, switched multi-megabyte data service, and FDDI, fiber distribution data interface. Asynchronous transfer mode. Asynchronous transfer mode is a network technology based on transferring data in cells or packets of a fixed size. The cell used with ATM is relatively small compared to the units used with older technologies. The small, constant cell size allows ATM equipment to transmit video, audio, and computer data over the same network and assure that no single type of data hogs the line. FDDI Basic Principle. The token ring network like IEEE 802.5, a special sequence of bits the token circulates around the ring. A station removes the token from the ring before transmission. After transmission, the station returns the token to the ring. Collisions are prevented as there is only one token in the ring. Physical properties of FDDI. Dual counter rotating token ring architecture. One ring is primary and other is secondary. Up to 500 stations with a maximum distance of 2 km between any pair of stations. For multimode fiber. With single mode fiber, the distance can be up to 40 km. Maximum ring length is 100 km. Total fiber length is 200 km for 2 rings. Uses 4B or 5B encoding. Benefits of FDDI. High bandwidth, 10 times more than Ethernet. Large distances between FDDI nodes because of very low attenuation in fibers. Improved signal-to-noise ratio because of no interference from external radio frequencies and electromagnetic noise. Best typical of fiber optic systems. It is substantially better than that in copper and microwave systems. It is very difficult to tap signals from a fiber cable. Limitations of FDDI. High cost of optical components required for transmission or reception of signals, especially for single-mode fiber networks. More complex to implement than existing low-speed LAN technologies such as IEEE 802.3 and IEEE 802.5. Applications of FDDI. Office automation at the desktop, backbones for factory automation, backend data center applications, campus LAN interconnection, intercampus backbones or metropolitan area networks, interconnection of private branch exchanges, workgroup or departmental LAN, integrated transport for multimedia applications. Advantages of MAN. It connects all of your computers and servers together on the network, and it is typically very fast, like 100 Mbps or 1000 Mbps. Applications of MAN. Email and surfing the internet are some examples of MAN. WAN, Wide Area Network. A wide area spans a large geographic area. It includes a state, province, or country. WANs often connect multiple smaller networks. They are such as local area networks or metro area networks. It is the single network that connects different sites, Layer 1 and Layer 2 operation. Purposes of WAN: Internet access, link sites within the same corporation, provide remote access to individuals who are off-site. WANs are characterized by high cost and low speeds. High cost per bit transmitted compared to LANs. Consequently, lower speeds, most commonly 128 kbps to a fewer megabytes per second. This speed usually is aggregate throughput shared by many users. Much slower than LAN speeds, 100 Mbps to 1 Gbps to the desktop. Network topologies. 3 fundamental shapes are bus, ring, star. Bus topology. Single cable connects all network nodes without intervening connectivity devices. Devices share responsibility for getting data from one point to another. Terminators stop signals after reaching end of wire. Prevents signal bounce. It is inexpensive and not very scalable. Difficult to troubleshoot, not fault tolerant. Advantages of bus topology. Works well for small networks. Relatively inexpensive to implement. Easy to add to it. Disadvantages of bus topology. Management costs can be high. Potential for congestion with network traffic. Ring topology. Each node is connected to the two nearest nodes. This is performed to the entire network. It forms a circle. One method for passing data on ring network is token passing. Active topology. Each workstation transmits data. Advantages of ring topologies. Easier to manage, easier to locate a defective node or cable problem. Well suited for transmitting signals over long distances on LAN. Handles high volume network traffic. Enables reliable communication. Disadvantages of ring topology. Expensive. Requires more cable and network equipment at the start. Not used as widely as bus topology. Fewer equipment options. Fewer options for expansion to high-speed communication. Star topology. Definition of star topology. Every node on the network is connected through a central device. Any single cable connects only two devices. Cabling problems affect two nodes at most. Requires more cabling than ring or bus networks. More fault tolerant. Easily moved, isolated or interconnected with other networks. Scalable. Supports maximum of 1024 addressable nodes on logical network. Advantages of star topology. Networking cables. Networking cables are used in many ways. It is to connect one network device to other network devices. This networking cable also connects two or more computers. It is used to share printer, scanner, etc. Transmission media. The term transmission medium or simply medium is referred to as cabling. However, this is no longer an accurate description. In places where a physical cable connection is not feasible, devices can communicate using wireless systems, specialized radio or infrared equipment. Twisted pair cables, unshielded twisted pair, shielded twisted pair, coaxial cables, optical fiber cables. Coaxial cable. Coaxial cable is called coaxial because it includes one physical channel. It carries the signal surrounded after a layer of insulation by another concentric physical channel, both running along the same axis. The outer channel serves as a ground. Many of these cables or pairs of coaxial tubes can be placed in a single outer sheathing and with repeaters can carry information for a great distance. Coaxial cable is sometimes used by telephone companies. They use it from their central office to the telephone poles near users. It is also widely installed for use in business and corporate Ethernet and other types of local area network. There are some factors determine the carrier's technology. Therefore, twisted pair copper wire and optical fiber may be used instead of coaxial cables. Coaxial cable invention. Coaxial cable was invented in 1980 by English engineer and mathematician Oliver Heaviside. He patented the invention. He also designed in the same year. AT&T established its first cross-continental coaxial transmission in the year 1940. Unshielded twisted pair. Unshielded twisted pair is the most common kind of copper telephone wiring. Twisted pair is the ordinary copper wire that connects home and many business computers to the telephone company. To reduce crosstalk or electromagnetic induction between pairs of wires, two insulated copper wires are twisted around each other. Each signal on twisted pair requires both wires. Since some telephone sets or desktop locations require multiple connections, twisted pair is sometimes installed in two or more pairs, all within a single cable. For some business locations, twisted pair is enclosed in a shield that functions as a ground. This is known as shielded twisted pair, STP. It is a side-by-side wire known as silver satin. The wall jack can have as many 5 kinds of hole arrangements or pinouts. It is depending on the kinds of wire the installation expects will be plugged in. For example, digital, analog, or LAN. Fiber optic cable. A fiber optic cable consists of a bundle of glass threads, each of which is capable of transmitting messages. It gets modulated onto light waves. Advantages of fiber optic cable. Fiber optics has several advantages over traditional metal communications lines. Fiber optic cables have a much greater bandwidth than metal cables. This means they can carry more data. Fiber optic cables are less susceptible than metal cables to interference. Fiber optic cables are much thinner and lighter than metal wires. Data can be transmitted digitally rather than analogically. Making connections of cables. Required tools: Cat5e cable, RJ45 connectors, cable stripper, scissors, crimping tool. Let us see what are the steps involved for making connection. First step is to strip cable end, untwist wire ends, arrange wires, trim wires to size, attach connector, check and crimp. Finally, test it. Internet working devices. In this session, we will learn about hubs, bridges, and switches, and routers. Why interconnect? To separate or connect one corporate division with another. To connect two LANs with different protocols. To connect a LAN to the internet. To break a LAN into segments to relieve traffic congestion. To provide a security wall between two different types of users. To connect WLAN to LAN. Many times it is necessary to connect a LAN to another LAN or to a WAN. Computers within a LAN are often connected using a hub. LAN to LAN connections are often performed with a bridge. Segments of a LAN are usually connected using a switch. LAN to WAN connections are usually performed with a router. Hubs. A hub interconnects two or more workstations into a local area network. When a workstation transmits to a hub, the hub immediately resends the data frame to all connecting links. Hubs expand one Ethernet connection into many. For example, a 4-port hub connects up to 4 machines. Bridge. A bridge connects networks. It also forwards frames. The frames are moved from one network to another. Selective forwarding. For example, if A sends a frame to E, the frame must be forwarded by the bridge. If A sends a frame to B, there is no reason to forward the frame. Bridge database. The bridge needs a database that contains information about which hosts are on which network. The realistic options are: the system administrator can create and maintain the database. The bridge can acquire the database on the fly. Transparent bridges. A transparent bridge does not need programming. but observes all traffic and builds routing tables from this observation. This observation is called backward learning. Each bridge has two connections, ports, and there is a routing table associated with each port. A bridge observes each frame that arrives at a port. It extracts the source address from the frame. It places that address in the port's routing table. A transparent bridge is found with CSMA or CD-LANs. Source routing bridges. A source routing bridge is found with token ring networks. Source routing bridges do not learn from watching tables. When a workstation wants to send a frame, it must know the exact path of network or bridge. If a workstation does not know the exact path, it sends out a discovery frame. The discovery frame makes its way to the final destination. Then, as it returns, it records the path. Remote bridges. A remote bridge is capable of passing a data. It can do it from one local area network to another. This process occurs when the two LANs are separated by a long distance. There is a wide area network connecting the two LANs. A remote bridge takes the frame before it leaves the first LAN. It encapsulates the WAN headers and trailers. When the packet arrives at the destination, remote bridge removes the WAN headers and the trailers, leaving the original frame. Switches. A switch is a combination of a hub and a bridge. It interconnects two or more workstations. But like a bridge, it observes traffic flow and learns. When a frame arrives at a switch, the switch examines the destination address and forwards the frame to the one necessary connection. Major role of a switch is isolating traffic patterns and providing multiple access. This design is usually done by the network manager. Switches are easy to install and have components that are hot swappable. The backplane of a switch is fast enough to support multiple data transfers at one time. Multiple workstations connected to a switch use dedicated segments. This is a very efficient way to isolate heavy users from the network. Full duplex switches. A full duplex switch allows for simultaneous transmission and reception of data to and from a workstation. This full duplex connection helps to eliminate collisions. To support a full duplex connection to a switch, two sets of wires are necessary. One to receive operation and one to transmit operation. Network servers. Network servers provide the storage necessary for LAN software. They are usually focal point for the network operating system. Increasingly, network servers are functioning as bridges, switches, and routers. By adding the appropriate card, a server can assume multiple functions. Routers. The device that connects a LAN to a WAN or a WAN to a WAN. The Internet uses IP addresses. A router accepts an outgoing packet, removes any LAN headers and trailers, and encapsulates the necessary WAN headers and trailers. Because a router has to make wide area network routing decisions, the router has to dig down into the network layer of the packet to retrieve the network destination address. Thus, routers are often called Layer 3 devices. They operate at the third layer. Sometimes, it functions on OSI network layer of the packet. Routers often incorporate firewall functions. Connection in general. The following connections are possible by routers. It acts as bridges for LANs and hubs. It switches for LANs and workstations. Routers for LANs and WANs. The Internet. Wi-Fi router. A Wi-Fi router is a device. It performs the functions of a router, but also includes the functions of a wireless access point. It is commonly used to provide access to the internet or a computer network. It does not require a wired link as the connection is made wirelessly via radio waves. Characteristics of wireless routers. 1 or multiple NICs supporting fast Ethernet. It also supports Gigabit Ethernet integrated into the main SoC. 1 or multiple WNICs supporting a part of the IEEE 802.11 standard family. It also integrates into the main SoC or as separate chips on the printed circuit board. It can also be distinct card connected over a mini PCI or mini PCIe interface. Some wireless routers come with either XDSL modem, DOCSIS modem, LTE modem or fiber optic modem integrated. IEEE 802.11n compliant or ready. Some dual-band wireless routers operate the 2.4 GHz and 5 GHz bands simultaneously. Some high-end dual-band wireless routers have data transfer rates at most 300 MB for 2.4 GHz band and 450 MB for 5 GHz band. Communications protocol. In the field of telecommunication, a communications protocol is the set of standard rules. They are created for data representation and signaling. It also ensures authentication. It helps to detect errors required to send information over communications channel. Example, a simple communications protocol adapted to voice communication is the case of a radio dispatcher talking to mobile stations. Introduction to TCP/IP networking. IP, Internet Protocol. UDP, User Datagram Protocol. RTP, Trace Route. TCP, Transmission Control Protocol. HTTP, FTP, SSH. Introduction to ISO network model. There are 7 network layers. Layer 1, physical cables. Layer 2, data link, Ethernet. Layer 3, network, IP. Layer 4, transport, TCP or UDP. Layer 5, session. Layer 6, presentation. Layer 7, application. Application layer. The application layer is the OSI layer closest to the end user. It means that both the OSI application layer and the user interact directly. This layer interacts with software applications. Such application programs fall outside the scope of the OSI model. Some examples include Telnet, File Transfer Protocol (FTP), and Simple Mail Transfer Protocol (SMTP), DNS, Web or HTTP. Presentation layer. The presentation layer provides a variety of coding and conversion functions. They are applied to application layer data. These functions ensure information sent from the application layer of one system, which would be readable by the application layer of another system. Some examples of presentation layer coding and conversion schemes include common data representation formats, the conversion of character representation formats, common data compression schemes, and common data encryption schemes are also part of it. Session layer. The session layer implementation of the OSI protocol suite consists of a session protocol and a session service. The session protocol allows session service users, SS users, to communicate with the session service. An SS user is an entity that requests the services of the session layer. Session service provides 4 basic services to SS users. Establishes and terminates connections between SS users and synchronizes the data exchange between them. Performs various negotiations for the use of session layer tokens, which the SS user must possess to begin communicating. Inserts synchronization points in transmitter data that allow the session to be recovered in the event of errors or interruptions. Enables SS users to interrupt a session and resume it later at a specific point. Introduction to Transport Layer. The OSI protocol suite implements two types of services at the transport layer. They are Connection-Oriented Transport Service and Connectionless Transport Service. 5 connection-oriented transport layer protocols exist in the OSI suite. It is ranging from Transport Protocol Class 0 through Transport Protocol Class. Connectionless Transport Service is supported only by Transport Protocol Class 4. Transport Layer Classes. Transport Protocol Class 0, TP0, the simplest OSI transport protocol. It performs segmentation and reassembly functions. TP0 requires Connection-Oriented Network Service. Transport Protocol Class 1, TP1 performs segmentation and reassembly. It offers basic error recovery. TP1 sequences protocol data units, PDUs. TP1 requires Connection-Oriented Network Service. Transport Protocol Class 2, TP2 performs segmentation and reassembly, as well as multiplexing and demultiplexing of data streams over single virtual circuits. TP2 requires Connection-Oriented Network Service. Transport Protocol Class 3, TP3 offers basic error recovery and performs segmentation and reassembly, in addition to the multiplexing and demultiplexing of data streams over single virtual circuits. TP3 also sequences PDUs and retransmits them to reinitiates the connection if an excessive number are acknowledged. TP3 requires Connection-Oriented Network Service. Transport Protocol Class 4, TP4 offers basic error recovery, performs segmentation and reassembly. It also supplies multiplexing and demultiplexing of data streams over single virtual circuits. TP4 sequences PDUs and retransmits them or reinitiates the connection if excessive number is not acknowledged. TP4 provides reliable transport service and functions with either connection-oriented or connectionless network service. It is based on the Transmission Control Protocol (TCP) in the Internet Protocol Suite and is the only OSI protocol class that supports connectionless network service. Network Layer. The network layer provides the functional and procedural means by which it can transfer variable length data sequences. It is performed from a source to a destination via one or more networks. It happens while maintaining the quality of service requested by the transport layer. Performance of network layer. The network layer performs network routing, flow control, network segmentation or desegmentation, and error control functions. That is IPv4, IPv6, ARP, RARP, ICMP, IGMP, RSVP, and IPsec. Datagram Network provides network layer connectionless service. VC Network provides network layer connection service, analogous to the transport layer services, but service, host to host. No choice. Network provides one or the other. Implementation in network code. Introduction to data link. The data link layer provides reliable transit of data across a physical network link. Different data link layer specifications define different network and protocol characteristics, including physical addressing and network topology. Physical addressing. Network topology consists of the data link layer specifications that often define how devices are to be physically connected, such as in a bus or a ring topology. Error notification alerts upper layer protocols that a transmission error has occurred. Physical layer. The physical layer defines the electrical, mechanical, procedural, and functional specifications. It is for activating, maintaining, and deactivating the physical link between communicating network systems. Physical layer specifications define characteristics such as voltage levels, timing of voltage changes, and physical data rates. It also defines maximum transmission distances and physical connectors. Introduction to Internet Protocol Address. An IP address is an identifier for a computer. It can also find a device on a TCP/IP network. Networks using TCP/IP protocol route messages based on the IP address of the destination. To view your IP address, you can use the ipconfig command line tool. ipconfig displays all current TCP/IP network configuration values. It also refreshes Dynamic Host Configuration Protocol (DHCP). It further activates and refreshes Domain Name System Settings (DNS settings). The format of an IP address. The format of an IP address is a 32-bit numeric address. It is written as 4 numbers separated by periods. Each number can be 0 to 255. For example, 1.160.10.240. It could be an IP address. Within an isolated network, you can assign IP addresses. It can be done at random as long as each one is unique. However, connecting a private network to the internet requires using registered IP address. It is also called internet addresses to avoid duplicates. An IP address can be static or dynamic. A static IP address will never change. It is a permanent internet address. A dynamic IP address is a temporary address. It is assigned each time a computer or device accesses the internet. Classes of an IP address. The 4 numbers in an IP address are used in different ways. This is to identify a particular network and a host on that network. 4 regional internet registries: ARIN, RIPENCC, LACNIC, and APNIC. Internet addresses from the following 3 classes. Class A supports 16 million hosts on each of 126 networks. Class B supports 65,000. It hosts on each of 16,000 networks. Class C supports 254 hosts. It has 2 million networks on each host. The number of unassigned internet addresses is running out. So, a new classless scheme called CIDR, gradually replacing the system based on classes A, B, and C. It is tied to adoption of IPv6. In IPv6, the IP address size is increased from 32 bits to 128 bits. Conclusion. In this chapter, we have covered the following aspects of networking concept: networking, local area network, metropolitan area network, wide area network, network topologies, networking cables, internet working devices, communications protocol, internet protocol IP address, MAC address, subnetting.